To build a deep learning model in Mipar, start by selecting the Deep Learning Trainer from the launch bar. Then, we can load our original images simply by dragging them in. In these particular images, we want to use Mipar and deep learning to identify true grain boundaries, as opposed to boundaries generated within the grains by twinning. The simplest way to start is to trace by hand the features that you want. So we'll start with a blank layer to trace on. Then we'll use our pen tool to begin. If it's not feasible to trace all of your images by hand, you can leave part of the image empty without ruining the model. Empty pixels will be ignored. Of course, with fewer annotations, the model will be less accurate. Alternatively, you can use a semi-automated or manually corrected workflow to accelerate your tracing, and then load the results into the deep learning trainer. Let's load some accelerated grain boundary tracings done previously. It's necessary for every model to have at least 2 different layers identifying 2 different classes of pixels. You can add a new blank layer to trace a second set of features. You can also quickly select background by adding the inverse of all layers. Let's save our session now in case we want to return to it later. Note that this session is the same as those produced by our batch, real-time, and post processors, so you can easily transfer images and layers from one to another. Now that we have our completed tracings, we can begin the training. If you happen to be using a GPU and find that the images are too big to fit in memory, you can use the training options here to split it up into tiles or scale the image down. Also, if your features are small and happen to be repeated across the image, tiling the image may improve the resulting model. So for our particular image, we'll use 5x5 tiling and a size factor of 1 and train the model for 500 epochs. Once you have your settings worked out, save these into the session. Now hit Train New to begin the training. We'll return once training has been completed. Now that we have our completed model, we can save it. To see the model in action, we hit Apply Model to load the first reference image in the image processor and apply the model to it. This Apply Model step is also available from the Deep Learning menu. So here we see our model loaded and applied to the reference image, outputting the probability map of our boundaries layer. Once you have your deep learning filter applied, you can then proceed with traditional algorithm development to reach your final analysis solution.